Back. Continuing with lecture 14 files, consider the palindrome.py. What is a palindrome? Palindrome can be a word or a string, a phrase or sequence that reads the same backward as forward. For example, madam, nurses run, nurses run. So you see, palindrome typically ignores the space. There are many such words. There are palindromic numbers. You understand palindromic numbers? 1, 2, 3, 4, 3, 2, 1. That's a palindromic number. Okay. So basically, what does palindrome file look at? It wants you to input a phrase or number or a string or any string basically, which is the same going forward as it is going backward. Okay, so you want to be able to, what nonsense, you want to be able to check that. Now I have an iterative approach first. Define a function is palindrome. You give it a test string, find the length of the string n, and a priori, that is upfront, say that your result is true. Now go in a for loop I in range until halfway to n. You understand? Halfway until n. If n is odd, say 15, then you're going until 7. Okay, because 8th one is by himself. So you're only going to check 7 and 9. You understand? 1 and 15, 2 and 14, 3 and 13, 4 and 12, and so on. Okay? Now, if at any point the I index is not equal to the opposite one, n minus 1 minus I index, anytime it's false, not true, then result is false, and you want to get out of the if conditional. So break is how you get out of it. Okay, so get out of the for loop. Otherwise, you could possibly change the result back to true even though it's false at some. So break is a way to get out of a loop. Okay, break does not get out of an if statement. Break gets out of a loop, for loop, while loop. So anytime result is false, get out of the loop and then return the result. If it is never the case that if this conditional is never satisfied, result is never updated, so you complete the test and the result continues to be true. That's why I needed to start with true. Okay, so here is main function, which will take help from is palindrome helper function. Let's run this. Please enter a string for palindrome test. Okay, madam, your string is a palindrome. Let me run it again. 1, 2, 3, 4, 3, 2, 1. It is a palindrome. So mind you, it will not, this code is rather simple. It does not take away spaces. For example, what was the example? Nurses run. So if you ignore the space, then nurses run and nurses run. Okay, this should be a palindrome, but our code does not ignore the space. So it's going to say it's not a palindrome. So if you like, you can work on this. In fact, that is a problem in Code Lab. which asks you to ignore. So somehow make sure that the spaces are taken away, all right, before you continue. So this was an iterative approach. Why? Because I went through a for loop. Here is a recursive approach. So let me hide away the first code, okay, and play with the second code, which is the recursive approach. Does it work? Let's see. Madam, it is a palindrome. Let me run it again. 1, 2, 3, 4, 3, 2, 1. It is a palindrome. Run it again. Nurses run. It is not a palindrome. So, good. This one works also. So, let's see. Forget the main. Is palindrome is the helper function. Everything else is the same. So, this is the base case. Always for a recursive approach, you must have a base case. If my test string has one character or less, that is, if my test string has no characters or exactly one character, then return true. Otherwise, well, check from index 1 until the index before the last. Make sure, so that is an AND, 0 index character is equal to the last character. So -1 index refers to the last character. Okay, so this is a slice of your string which takes away 0 index and takes away -1 index. The rest of it must be palindrome. The very 0 index and the last index must be equal. They both should happen. Then you get a true, otherwise it's a false. Okay, so this is the recursive approach. So this was also a functional recursion. My function had the same function called inside it. Okay, this is a functional recursion. The next example is also going to be functional. One more example on the functional case. Until then,